So today we're going to do a little code review of the code I've been developing. Now this code is capable of doing both the belt trick that we talked about, and it is also capable of doing John Macken's wave, electron wave model. Okay, so but what we're going to do is we're going to go through the code. We're going to go through all the parts of the code, and hopefully by the time we're done this, you will have a better idea of how the code works, and then you'll be able to play with it yourself and maybe come up with some new ideas on how to use this code. So the first two parameters here define the extent of the grid. Okay, so the first one, the grid size, is really the number of objects in each direction, so the number of divisions along one axis. And the grid extent is really the size of the grid. This would be more the physical parameter, which we divide by 10. If I didn't divide by 10, then I'll show you what will happen. If we didn't divide by 10, then the spacing between the grid would be too big. So this basically defines the spacing between the grid. Okay, so this the first two parameters define the extent and the quality of the grid. Okay, so the next parameter here, the maximum twist, which defaults to 180 degrees, which is really the number of turns. And so here I have the windings parameter, which you may have seen before if you looked at the code, and this is like a half a winding, which is 180 degrees. So in my user interface, I define winding instead of the angle. I want to know how many turns, and so 0.5 is the number of turns. And so as you see, so let's have a look here. Let's go to this one here, so it's bigger. Okay, so if I increase the number of turns, you see that increases the number of windings. Okay, so if I increase, I have a maximum of five windings. This means that the winding has turned around 5 times. And if I set this to 0, there are no windings, and then there's everything in between. So as I increase the windings, you increase the twist of the model. So the next parameter here is the power factor, and what this does is it increases and decreases the range of the deformation. So this is if the power factor is small, the only a small region of the grid is affected, and when the power factor is big, then a larger region is affected. So you can expand or contract the region. If I set it up really high, of course you get this crazy thing happening here. So really you want a low to medium. You don't, the further you go, the further out the deformation is, and so now we're affecting the whole grid extent here with the higher value, and when we make it smaller, we are only affecting a smaller region of the grid. So the next two parameters are the speed and the phase. Okay, and then there's this flag that says auto increment phase, and when you turn that off, so when you turn this off, the phase stops, and then you can manually adjust the phase, so you can look at any phase of the rotation that you want. And the rotation speed, if we turn this back on, then the rotation speed will increase the speed of the rotation. Okay, and basically this is just skipping angles, and so when you increase the rotation speed, really what we're doing is we are skipping. So instead of visualizing every angle at the low speed, then we are visualizing every maybe 5th angle or every 10th angle at the faster speed. And so that's how we're able to speed up and slow down the visualization. So these next two parameters are to be used to store a list of positions for each position in the grid. And so the original positions will be the original positions in the grid, which is basically going to be just the locations of where all the points are, where all the objects are in the grid. Okay, and then the current positions are going to be the new locations, which are going to be applied when we want to actually visualize the wave in the grid. Okay, so the grid is the medium. You can think of the grid as the medium, and the wave is a deformation in the medium, and that is what we are calling, so the original positions are here, and the new positions are when we apply the deformation. Okay, so that's what these two parameters are going to be used for. Okay, so this GUI, GUI is just graphical user interface. The graphical user interface is this guy here. Okay, and the orbit enabled, so this is a flag used to turn on and off the orbit orbit control, which is basically the ability to manually rotate the grid and look at it from different angles. Okay, so now these parameters here are just flags where I can turn things on and off. And so right now you can see that I'm drawing cubes. Okay, if I turn draw cubes off, so if I set this to false, okay, it is going to default to drawing spheres. So originally I was drawing spheres, and I liked that. Okay, I like the spheres, they look really cool, but it's really hard to tell the orientation when we use spheres. And so instead I have, I'm going to set this back to true, and you will see that now I am drawing cubes. And when I draw cubes, it's easier to see that these objects are changing orientation as well as changing their position. So they're offset from their original position, and they're being oriented in different orientation depending on their location within the wave. Okay, so this parameter, the do belt, if you set this to true, instead of doing the wave, John Macken's wave model, it is going to do the belt trick. Okay, we're doing the belt trick now, and you can see, I'm going to actually show a close-up of the belt trick here, and you can see that if you increase the power, it increases the extent of the belt deformation. And when you increase the windings, it increases the windings. So you can see that we got more and more windings as we've got like 5 windings. You can actually count the windings when you're in, this is stopped. Okay, I'm going to stop this. I'm going to set this to 90 degrees approximately. And then we're going to see, you can see the winding. You can see the belt winding up. Okay, so that's what this parameter is for. When you're looking at the belt, then it's easier to see the windings winding up. And so this is a nice way of getting to the belt trick. You just set this to true, and then you can see that we now have the belt trick. Okay, and so the belt trick, also you can have the belt extent. So if I set this from, say, 0.3 to 0.5, let's say, then you're going to get a thicker belt. Okay, let's have a close look here. Then you're going to get a thicker belt. Okay, that expands the extent of the belt. Okay, and if you make it smaller, let's say we want to make it like 0.1. Okay, then you just get a very thin belt, and this is kind of useful. I actually discovered a bug by looking at it this way. And so you can just see it's just showing the very middle cubes, the very middle of the visualization, the very, very middle of the belt. And so then what I wanted to do was this is very, the camera view is a little wonky in this, because if you zoom in too much, then you're actually looking on the inside, it's clipping, and I don't know how to fix that. But if you look at this, you can look at the very middle. The very middle one is red, and what red means is that it is not changing position, but it is still changing orientation. Okay, let me zoom in a little bit. Try to get this just right. Sorry about that. Anyways, yeah, you can see this. You can look at this yourself more closely. You can see that the middle one, the middle cube, is just orienting, and so I was able to use that to see whether my orientations were, whether my windings were implemented properly, or whether my visualization was implemented properly, and I found a bug and I fixed it, and now it's working properly. Okay. Okay, so I'm going to set this back to 0.32, and then I'm going to set this equal to true. And so what this is going to do is it is going to, let me just save that. It is going to, and actually I think this, if you want to see this full screen, then what you do is you click share and you click the middle one here, and what this will do is it will bring you to a full screen view of the visualization. And so here what we see, what I did was I put a few objects into the middle just to show, just so you can see what's going on here. And then this is how I'm able to visualize the, let me just zoom in a tiny bit more. I don't have my mouse with me, so I'm doing this with the computer touchpad, and it's very touchy. Okay, so here you can see that these objects spin around twice. So let me just slow it down a bit. It's easier to see when you go slow. Okay, so let's look at this guy here. So it spins around once. When it spins around once, the belt is down. And when it spins around once again, the belt is up. So this spins around 2 times for this to get into the same state where the belt is up and the belt is down in the same orientation. So that is what they mean by the object has to spin around twice to get back to the same state. So the first time it spins, it's in this state, and the second time it spins, it is back to its original state. Okay, so that's what that is all about. Okay, so I'm going to go back to the John Macken's visualization. Okay, to look at the next feature, I want to look at John Macken's visualization, but I don't want to show the center object, so I'm going to set this to false. Okay, and now we're back to John Macken's visualization. And so what I want to show you now is the add layer. So when you look at the, let's go back to John Macken's, the bigger one. Okay, so there is a feature in here called add layer, and what this does is it adds the layers, but it adds the layers below the deformation. And what I wanted to see here was that the further away you get from the center of the deformation, the less effect you have, the less deformed the medium is. And so I wanted to do this in an effort to visualize the bulk of the medium, because I'm trying to simulate the bulk of the medium of the ether. The ether is not just a thin plane. You can remove these layers. Okay, the ether is not just a thin plane, it is a bulk. And so this, I want to simulate the bulk of the medium, but I also want to see the wave. I want to see what the wave looks like at the center, and I want to see what the wave looks like when you're looking far away from the medium. So you're still seeing a deformation here, it's just not as much. But in my code here, if I set add layer symmetrical, if I set this to true, okay, let's run this, and actually I'll save this, and I want to run, let's share the full screen. Okay, when I set the layer symmetrical to true, now what it's going to do is it's going to add the layers symmetrically at the top and the bottom. And so now you can see the bulk of the medium being deformed, but you can't see the inside of the wave anymore. You can't see the central region anymore. And so what I did instead was I added this feature here to do half. So what it's going to do is it's going to show only half of the medium. And so let's go to the full screen again. Excuse me. Okay, so now you see that we're only seeing half of the medium. Okay, so you can see there is the central region of the medium. And now when we add layers, we're adding them symmetrically, but now we can see I'm going to speed this up because when I add layers, it really slows down. Okay, so now you can see the deformation happening in the central region. You can see what's going on with the wave. Even though I have symmetrical layers top and bottom, we can actually look at the inside of the wave. Okay, so that is I think all of the features that I have in my code that allow us to change. I do have this other coloring, which let me set this back to false. Okay, I'm not going to worry about the layers right now. So I have another coloring where I color based on a distance from the center of the deformation. So let's just have a look at this closer. Okay, so in this visualization, I'm colorizing based on the distance from the center from the origin. And in this visualization, I'm displaying colors based on the distance each object is from the original position. And so if the color is red, it means that the object is very close to its original position. And when the object is when the objects are yellow, from red to orange to yellow, then they are further away from their original position. And you can see as I increase the winding, then you get into the blues and then the purples. So purple is farther away, blue is getting closer, green is getting closer, yellow is getting closer, and then red is basically all of the objects are in their original position when the windings are 0. Okay, so a similar thing happens with the power. Okay, as I increase the power, then you get the other colors. It goes into the other colors, but if you decrease the power, then the objects are not being displaced as much. They're closer to their original position and they're closer to the red color. Okay, so I'm going to set this back to true because I want to colorize my objects based on the distance from the original position, which looks like this. Okay, so, and you're seeing some flashing here. You're seeing these pink flashes, and this is because I set up a lighting system in my software. I set up a lighting system, and every once in a while the lights reflect off of the surfaces, and you get these kind of flashes. And so I don't need to do that, but that's what my software is doing right now. I like that the fact that the objects look that there's a bit of shading in the objects. They look, you know, cubes look like cubes and spheres look like spheres. And so, but I do have this artifact of the surfaces reflecting off the lights. And I didn't really spend too much time with the lighting system. I just asked ChatGPT to give me a nice lighting system that makes objects look more three-dimensional, and that's what I got. So that's what I'm going to be using. You can play around with the lights and do interesting things. You can do whatever you want with them, but this is what we are going to work with today. So unfortunately, we are about 20 minutes into this video, and I haven't even gotten into the guts of the code yet, and I have to get to work. And so I am going to split this video up into 2 parts. And so I will get into the guts of the code in the next video, but I will put a link to this code into the description, and so you can start looking at it. I also put it into the last video, so you can get the code and start playing around with it if you like, and then I will get into the guts of the code in the next couple of days. And so sorry about that. I didn't realize it would take so long just to get this far, and so I'll be back to do part 2 of the code review, and otherwise I hope you all have a great day, and I'll be back.